Hello everyone, welcome to CodeChef. Myself Jwala and today we are gonna solve the problem which came with the starters 219. The name of the problem is ones and zeros 1. The problem code is OZ1. The difficulty rating of the problem is cakewalk and the prerequisite is at all. Let's start with reading the problem statement over here. So guys, problem over here. So guys, problem says given a binary string f of s is defined as follows. A prefix s of 1 comma I is called code if it contains at least as many ones as zeros. F of s is the number of code prefixes of the string s. You are given a binary string s of length n. Find f of s. Input format. The first line of input will contain a single integer t, denoting the number of test cases. Each test case consists of multiple lines of input. The first line contains an integer n. The second line contains a binary string s of length n. Output format for each test case, output on a new line, two integers, the maximum f of s, and the minimum swaps to obtain the maxima. Constraints for t lies from 1 to 10 to the power 4, for n lies from 2 to 2 into 10 to the 10 to the power 5, and absolute value of s equal to n. S of I belongs to 0, 1. The sum of n overall test cases does not exceed 2 times of 10 to the power 5. So guys, now let's understand the sample test case in the question more precisely here. So guys, this question is very straightforward. It says that given a binary string f of s is defined as follows, where the prefix of s of 1 to index I is called good if it contains at least as many ones as zero. I mean similar number of ones and zeros. Okay, and f of s is the number of good prefixes in that string s. Okay, so we have to find such many substrings within that string basically. Okay, we have to find that count. Okay, let's take the first test case. We have got 3 and this is 0 0 0. So there are no good prefixes, yeah, because there are all zeros, no one. So for good uh for it to be good prefix, it has to be same number of ones and zeros. Okay, so doesn't have any. So output f of s would be simply 0. Okay, let's go for some other test case. Uh, okay, so let's go for test case 3, which is 5 0 1 1 1 0. Okay, so all prefixes are good except for s of 1 comma 1. Okay, so yeah, so we can say how many? 4. Simple, guys. So this is a very simple question. You just have to see and bring a ad hoc solution. Now let's move toward the simple solution. So we simply need to check for each prefix of s if it contains at least as many zeros as 1. Okay, so this can be done easily by maintaining a running count of zeros and ones. Specifically, let z and 0 denote the number of zeros and ones in the current prefix. Initially, these values are both 0. For each I from 1 to n in order, if s of I equal to 0, add 1 to z. Otherwise, add 1 to 0. Then if 0 is greater than or equal to z, add 1 to the answer. In the end, we have to print the answer. So guys, I think the solution is very clear. Now let's move toward the simple C++ code for this question. So guys, this is my simple C++ code for the question. I took the input for all the test cases as well as string s. I initialize zeros and ones equal to 0 and answer is equal to 0. I'm running a for loop. Over here I'm checking if s of I equal to 0. I will increment the zeros count, else ones count. And checking if ones is greater than or equal to 0, I will print answer. I will increment answer and at the last I will simply print answer. And as you can see that guys, I have got my C++ code right. Now let's move towards my Python code. So guys, this is my similar Python code. I took the input for all the test cases as well as n and s. I initialize zeros and 1. Okay, 0, 0. Answer equal to 0. I'm running a for loop in range up till n and checking if s of I equal to 0. I will increment zeros plus equal to 1, else ones plus equal to 1. Once is greater than or equal to 0, I will increment answer count and at the last I will simply print answer. And as you can see that guys, I have got my Python code right. So guys, I think the solution, the code and the approach is pretty much clear. Now let's meet in the next video. Thank you so much guys for watching our videos.